Welcome to our deep dive on essential Docker commands.
Right.
We're going to be exploring excerpts from Master Docker 712.pdf.
Okay.
And by the end of this, you'll have a solid grasp of Docker.
Yeah,
Whether you're prepping for a meeting or getting up to speed or just curious.
that's right. We're going to unpack the core set of skills you'll need to work effectively with Docker.
So let's start with the fundamentals: building images, running containers, and managing the Docker daemon.
Okay?
These are covered in points 17 through 21 of the source material.
Right.
What stands out to you in this section?
Well, one thing that's crucial for real-world applications is the interplay between networking and volumes.
Okay.
Networking enables your containers to communicate with each other and the outside world,
Yeah.
while volumes handle persistent data storage and sharing.
I see we have commands like docker build dash dash no cache for efficient building.
Right.
Can you elaborate on when this would be particularly useful?
Absolutely. Imagine you're working on a project and you've just updated some dependencies. Using the dash dash no cache flag ensures a fresh build that incorporates those changes instead of relying on potentially outdated cache layers.
Makes a lot of sense. So for interactive work inside a container, we have docker run it image.
Mhm.
It's like stepping right into the container's environment.
Yes, exactly. And speaking of environments, you brought up networking.
Okay.
Commands like docker run dash dash network and docker run dash dash address give you fine-grained control over how your container connects.
Right.
You can specify which network the container joins or even assign a specific IP address.
Okay. And I see docker run -v host -path.container path for mounting volumes. These volumes act as external storage for containers, right?
You got to think of them as dedicated hard drives for your containers, ensuring your data persists even if the container is deleted.
Okay.
You can use the -v flag to mount a directory from your host machine directly into the container.
So if I'm working on a project inside a container,
Right.
I can use volumes to make sure my work is saved even if I delete the container later?
Precisely. And there's also the -- mount flag,
Okay.
which provides even more granular control, especially when working with Docker's advanced volume features.
Now let's shift gears a bit. We've talked about creating containers, but what about inspecting, cleaning up, and managing plugins?
Right.
Points 22, 23, and 24 touch on these aspects.
Okay.
What are some key takeaways here?
One of the most powerful commands here is Docker inspect.
Okay.
Think of it as Docker's X-ray vision.
Okay.
It lets you see the inner workings of containers and images, giving you detailed information about their configuration and status.
So if something isn't working as expected,
Right.
Docker inspect could help me understand why.
Absolutely. And then we have commands like docker arm-container and docker arm-if image for forcefully removing containers and images.
Important to use those with caution, though, right?
Exactly.
It's like permanently deleting files on your computer.
Exactly. Always double check before you use the DAF flag.
Right.
Now, you also mentioned plugins.
Yeah.
Docker plugins extend Docker's functionality, and you can manage them using commands like docker plugin else, docker plugin install, and docker plugin remove.
So it's like an app store for Docker, adding features as needed.
Right.
Now I'm curious about real-time debugging. Is there a way to see what's happening inside a container as it's running?
You're thinking of docker logs-container.
Oh.
This command lets you follow the logs in real time,
Right.
which is incredibly useful for debugging. It's like having a live stream of events within your container.
Okay, so if my application inside the container throws an error,
Right.
I can use docker logs-f to see exactly what happened and when.
That's right. It can be a lifesaver when trying to track down those tricky bugs.
Now we've been talking about single containers, but what happens when we need to work with multiple environments? For instance, having separate setups for development, testing, and production.
That's where Docker contexts come into play.
Okay.
You can use Docker context alls to list your available contexts. Docker context create context to make new ones, and Docker context use context to switch between them.
So instead of manually configuring each environment every time,
Right.
I can simply switch contexts. That streamlines the workflow considerably.
Exactly. It's a real-time saver when dealing with complex setups.
Now let's talk about resource management points. 26 and 28 highlight some interesting commands for controlling how much CPU and memory our containers use.
Right. We have Docker update -- CP shares value container for adjusting CPU priority, and Docker update -- memory value container for setting memory limits.
So it's like setting boundaries for our containers,
Mhm.
making sure one doesn't hog all the resources and impact others.
Precisely. You can fine-tune resource allocation to optimize the performance of your entire Docker environment.
And to wrap up this section, let's talk about updates.
Oh.
How do we ensure our Docker environment is up to date?
We can check the versions of both our Docker client and server.
Okay.
To see the client version, use Docker version -- format.
Okay.
For the server version, it's Docker version -- format.
Okay.
Server version. For the server version, it's Docker version -- format.
So before we dive into the more advanced aspects of Docker, we've covered the essential commands for building, running, managing, and even cleaning up containers.
Right.
But there's a lot more to explore, right?
Absolutely. In the next part of our deep dive, we'll delve into the world of Docker files, the blueprints for building container images.
Okay.
We'll also touch on orchestration with Docker Compose and some of the more advanced networking features Docker offers.
Great.
Welcome back, ready to explore Docker files and orchestration.
Absolutely. We touched on Docker Compose earlier, describing it as a tool for managing multi-container applications.
Yep.
Can you elaborate on how it works and why it's so valuable?
Certainly, Docker Compose uses YAML files,
Okay.
which are essentially recipes for your applications.
Right.
These files define the service of networks and volumes needed to run your app.
Okay.
All in a human-readable format. Docker Compose takes this recipe and orchestrates the entire setup for you.
So if I were building a web app with a database backend, I could define both the web server and database as separate services in my YAML file.
Precisely, you can specify the image for each service, the ports to expose the environment variables to set
Wow.
all the crucial details for each part of your application.
That sounds incredibly efficient. I also noticed the term depenson in the source material.
Yeah.
What's its significance in this context?
That's a critical feature for ensuring services start up in the correct order.
Okay.
Let's say your web server needs the database running first.
Right.
You can use depenson to tell Docker Compose to launch the database container before the web server.
So it acts like a built-in dependency manager for your containers. Fascinating. Earlier, we briefly mentioned Docker's advanced networking capabilities.
Right.
What makes them so advanced?
Docker's networking provides granular control over container communication, both with each other and the outside world.
Right.
You can create custom networks to isolate containers
Okay.
and even configure advanced features like IP address management.
I see terms like driver and IPAM in the source material related to networking.
Yeah.
Could you shed some light on those?
The driver option lets you choose the underlying technology for your container network.
Okay.
Docker supports various drivers,
Right.
each with its own strengths. For instance, the bridge driver is suitable for simple setups,
Okay.
while the overlay driver enables communication between containers across multiple hosts.
Okay.
IPAM allows you to fine-tune IP address allocation and subnet configurations within your container networks.
So we have choices depending on the complexity of our network setup.
Exactly. You can tailor the networking to the specific needs of your application.
Now, shifting gears to scaling, how do we transition from running a single container to managing a fleet of them?
This is where Docker Compose truly shines.
Okay.
You can use the Docker Compose up -- scale service replicas command to easily scale a service to the desired number of instances.
So if my web app suddenly experiences a traffic surge,
Right.
I can spin up more instances of the web server container to handle the increased load.
You got it. Docker Compose distributes traffic across these replicas,
Right.
ensuring your app remains responsive even under heavy load.
That's incredible, but scaling is just one aspect of deployment.
Right.
How do we actually get our applications out into the world?
The source material mentions Docker Swarm
Right.
and the Docker deploy command.
Right.
This is where those come into play.
Huh.
Docker Swarm is an orchestration tool
Okay.
for managing a cluster of Docker nodes
Okay.
and deploying applications across them.
So instead of being limited to a single machine,
Mm-hmm.
we can distribute our containers across a whole swarm of servers.
Precisely. Docker Swarm allows you to deploy your app as a stack,
Okay.
which is essentially a group of services defined in your Docker Compose file.
Right.
The Docker deploy stack command handles deploying the stack to the swarm,
Okay.
distributing the containers across the available nodes.
This sounds incredibly powerful for high availability and fault tolerance.
Right.
If one server goes down, the application can continue running on others, right?
Yeah, exactly. Docker
Yeah.
Swarm ensures your application stays up and running even if individual nodes within the swarm experience issues.
This level of resilience is impressive. So we have our swarm, our stack deployed, and our application running. How do we monitor everything and ensure it's all running smoothly?
Docker Swarm provides several commands for managing and monitoring your deployed applications.
Okay.
Docker Stack lists all deployed stacks in the swarm.
Got it.
For a deeper look, Docker Service Inspect service provides detailed information about a specific service within a stack, including its status replicas and configuration.
It's like having a comprehensive dashboard for our entire Docker swarm, but what about troubleshooting things inevitably go wrong?
Yeah.
How do we diagnose and fix problems in this distributed environment?
Troubleshooting in a swarm can be complex, but Docker offers tools to help.
Okay.
The Docker exec, a container bin bash command, allows you to access a running container shell, enabling you to execute commands and investigate issues directly.
That's like having a remote terminal into our container.
Exactly, and we can use Docker inspect -- format JSON state container to get a detailed JSON representation of a container state.
Right.
This information helps in understanding why a container might not be behaving as expected.
And logs are always crucial for debugging, right?
Absolutely. Docker logs -- tail number container fetches the last few lines of logs from a container, often revealing the source of an error or unexpected behavior.
So we have tools to access containers, inspect their state, and analyze logs, giving us a comprehensive toolkit for troubleshooting in a Docker swarm. This is starting to feel less daunting, but what about security? How do we protect sensitive information within our Docker environment?
Docker offers secrets management for this very purpose.
Okay.
It allows you to securely store and manage sensitive data, like passwords, API keys, and certificates.
Got it.
You can create secrets, grant access to specific services, and even rotate them regularly for enhanced security.
So instead of hard-coding sensitive information into our code or environment variables, we can store it securely in Docker and control which services have access.
It's a much safer approach aligned with security best practices.
That makes a lot of sense. Now, the source material also mentions Docker configurations management.
Yeah.
What's its role?
Configurations are similar to secrets, but are intended for non-sensitive configuration data, such as application settings or environment variables that don't require the same level of security.
So it's a centralized way to manage configuration data separately from our code, making updates and rollbacks much easier.
Right.
We change a configuration value in one place, and Docker propagates the change to all affected containers.
Precisely. It simplifies configuration management considerably.
We've covered quite a bit about managing containers and applications. What about advanced techniques for volume management? Earlier, we discussed the basics, but I'm curious about more sophisticated approaches.
Docker offers several tools for advanced volume management.
Okay.
For instance, Docker Volume Prune removes all unused volumes, helping you reclaim valuable disk space.
So it's a way to clean up and optimize our storage usage.
Exactly. And if you need to fine-tune resource allocation for your volumes, options like --eputpus and --memory swappiness give you more granular control.
Okay.
--shepus limits the number of CPU cores a container can use, preventing resource-intensive containers from monopolizing processing power.
Right.
--memory swappiness controls how aggressively a container swaps memory to disk, which can impact performance.
This level of control over resource allocation is impressive. We can tailor resource allocation to each container's needs, optimizing performance across our entire Docker environment.
And don't forget about the flexibility of managing and switching between different Docker contexts.
Right.
This is especially helpful when working with multiple environments or cloud providers, for example. You can create a new Docker context that points to a specific Docker host. Using Docker context, create context name -- Docker host.
Okay.
And then effortlessly switch between contexts using Docker context. Use context name.
Wait, we can create contexts that point to different Docker hosts? This means I could have a context for my local development environment, another for a staging server in the cloud, and yet another for a production environment on a completely different cloud provider.
You've got it.
Wow.
This feature makes managing complex deployments across multiple environments remarkably straightforward. You can switch contexts seamlessly, eliminating the hassle of manually configuring environment variables or connection settings.
This entire deep dive has been an eye-opening experience. We've gone from basic commands to orchestrating multi-container applications across entire swarms, managing secrets and configurations, fine-tuning resource allocation, and even switching between different Docker environments with ease.
It's clear that Docker is much more than a simple containerization tool.
Right.
It's a comprehensive platform for building, shipping, and running applications at any scale.
Absolutely.
But even with all the power and features we've discussed, it's important to remember that mastering Docker takes time and dedication.
Absolutely. There's always more to learn and explore in the Docker ecosystem.
Right.
And I'm sure our listeners are eager to hear your recommendations on how to continue their Docker journey.
In the final part of our deep dive, we'll discuss resources and strategies for continuous learning and development in the world of Docker.
We've covered a remarkable amount of ground in this deep dive, from the fundamentals of Docker commands to the complexities of orchestration, security, and resource management. It's clear that Docker is a powerful tool with a lot to offer. But as you mentioned, mastering it takes time and dedication for our listeners who are just starting their Docker journey or even those looking to expand their knowledge. Where do you recommend they go from here?
One of the best things about the Docker community is the wealth of resources available to support learning and growth. Docker's official documentation is a fantastic place to start. It's comprehensive, well-organized, and covers everything from basic concepts to advanced use cases.
It's like having a detailed manual for navigating the Docker world. But sometimes you need more than just documentation. Where can our listeners go for practical tips, troubleshooting help, or perhaps some inspiration from others in the Docker community?
The Docker community is incredibly active and supportive. You'll find vibrant online forums, dedicated Slack channels, and a wealth of blog posts and tutorials created by experienced families. Docker practitioners engaging with these communities can provide invaluable insights and support.
It's like having a global network of Docker experts at your fingertips, ready to share their knowledge and experiences. But beyond community resources, what advice would you give to someone just beginning their Docker journey? What mindset or approach should they adopt?
Embrace the learning process. Docker can seem overwhelming initially, but don't let that discourage you. Start with the basics, experiment with the commands we've discussed, and gradually build your knowledge and skills. Remember, the Docker community is there to support you every step of the way. Don't hesitate to ask questions and seek help when you need it.
That's great advice. Don't be afraid to experiment, make mistakes, and learn from those experiences. And most importantly, have fun exploring the possibilities DAW offers. This deep dive has been a fantastic journey, uncovering the power and versatility of Docker. We've explored everything from basic commands to managing complex distributed applications.
It's been a pleasure sharing this deep dive with you, and our listeners remember, Docker is a continuously evolving ecosystem. Stay curious, keep experimenting, and never stop learning.
And to our amazing listeners, thank you for joining us on this exploration of Docker. We hope you've gained valuable insights and a newfound appreciation for the potential of containerization. Until next time, happy containerizing.